binomial experiment, right? We got a couple of things going on. So really, right, you have two outcomes, fixed number of trials, trails, whatever. That's my dyslexia getting the best of me. What else? Let's see. Each probability of success has to be constant, right? I'll write that like this. What's the fourth one? So binomial, you're doing the same thing over and over again. What's the fourth condition? I got all day. Only 48 hours ago, I told you. That's correct. All the trials have to be independent. Who said that? Oh, good job, Mara. Thank you. Right, so the trials are independent. You might think that that comes from them being constant, right? But that's not quite the same thing. But yeah, so each trial can affect the other one. So, right, Bobby said that like he thinks that that wasn't the case with someone shooting free throw. So I was like, Bobby, please just use your imagination, right? He's got ice in his veins, but he's also an idiot, all right? So like that's just how that goes. So remember, this is the formula that I taught y'all, right? So, for example, we had something with Drippy where there was 5. So he was doing, we want to figure out what's the probability that he gets exactly 3 free throws if he shoots 5, right? Shoots 5, we want to know what's the probability he gets exactly 3. And that's the probability of him getting 1, which we said, I think, 57. Right, which means his probability of missing is 43. So you take, not this to the x, this should be to the x, which was 3. This is 2, right? Should have also give you a hint maybe on how to do that right there. Should give you a hint on how to answer one of the problems on the celebration, right? That would have told you the Professor Douglason question. So strategy, you got to determine if it's a binomial experiment, which means it has those 4 conditions. If yes, you just determine n, p, and x, and you plug it into that equation, right? So here with an example, they're both binomial, right? So you just plug it into this formula, right? Exactly 6 out of 4 employees satisfied. 6 choose 4 ways to arrange those employees, right? In different orders, right? For each of those orders, the probability that you would get into that, right? All right, I got 4 satisfied. So that's 38 to the 4th, right? 38 times itself repeatedly. That's how you multiply when you have independent events, right? Times 0.62 squared. The stuff, the little bit in there. But once you got it, you have it, right? This stuff, so just be able to recognize binomial, recognize these formulas. None of them are out of this world. You should be able to memorize them. And you won't have to, because you can write it down, right? You get a note sheet, but still good to memorize them. All right, we remember all of this from Monday, right? All right, let's see how this is done. So let's look at, remember, these are examples of probability distributions, right? So probability distribution is where you have some x values, right, that are possible, and each of them has a particular probability. Trying to find my notes. All right, so let's find the probability distribution for the number of girls, right? All right, so let's kind of try to think about this. All right, family has 3 children, so what are the possible values of x? This is easy, everyone should just tell me them very quickly. The lowest possible value of x, everybody, is 0. We got 1, 2, and 3, all right? Is this a binomial situation? Are we doing a fixed number of trials? Kill me here. Think of each birth as a trial. How many births are there? So that's a fixed number, right? How many outcomes are there for each birth? 2. It's either a girl or it's not, right? Is each birth, some of you know more about biology than I do, is each birth an independent event? Yes, right? And is the probability constant? Thank you. Probability is constant because the probability for a girl being born, whether it's the 1st, 2nd, or 3rd, it's 1/2, right? So this is a binomial situation. Is everyone able to understand when something's binomial? You're basically repeating something over and over again. Notice this experiment is identical, perhaps much easier because there's no childbirth involved, to flipping a coin 3 times in a row, right? So this is binomial, all right? If you don't understand why, please ask, right? All right. What is P? You guys are killing me. P. P stands for probability. What's P in this case? Mars, it's okay. You weren't listening because you were working. Everybody should be able to tell me what P is immediately. P stands for probability. Probability of a single trial being successful. What? No. Very straightforward. It's 0.5. We're doing a trial. We're birthing 3 children. The probability of success here, it's the probability of a girl, right? Because that's the probability distribution. P is clearly 0.5 or 1/2, right? Do we get this now? All right, so probability of a success is P. How many trials are being done here? 3. Okay, the other number we need is X. But we're filling out the whole distribution, right? So when you're filling out the whole distribution, you're not choosing one X. You're doing all of them. Does everyone follow what I'm saying here? Because we need to figure out what's the probability. Y'all have no girls, 1 girl, 2 girls, 3 girls, etc. The distribution, right? X is the number of girls, right? Hopefully we're following this example. For not, I'm a little worried, okay? So let's just go through how you would do this. Oh, here's the formula you use. N Cx P to the X, 1 minus P to the N minus X, right? N is 3. X we're varying, right? P is 0.5. And notice the nice thing here is that 1 minus P in this case is also 0.5. So for example, probability of getting exactly 1 girl, they just knows this is this formula right here with X plugged in, with 1 plugged in as X. All right. No particular, so they're just choosing to use 1 as the example that they're doing, right? So this is the probability that there's 1 girl. We're going to do this for all values of X. It's just a sample calculation of one of them. The other ones will be here, but smaller, right? So let me just show you. It's done with all of them, right? Notice 3 choose 1. 3 choose 1, everybody, is what? Is equal to what? So 3 choose 1 means how many ways can I choose 1 object from 3 objects? And the answer is 3. So this is 3 times 1/2 times 1/2 squared. This is 1/4 times 1/2, 1/8, 3/8. They're just using the formula to fill out this table. It is fairly straightforward, right? All you're doing is using this formula, which is not magical. It's very straightforward. We went through how to get this formula from the drippy free throw example, right? Questions on this?
That's considered your sample space?
This would be considered your probability distribution. Bobby, you look like you have a question.
Yeah. I have a question and I don't know how to ask it.
I'll give it a shot.
So when I put this in like calculator or going to solve this, I'm like confused how to do it on my own because I get what you're saying, but at the same time I don't know how to do it on my phone. And that's what's like throwing me off.
Okay, do you know how to exponentiate on your calculator? Yes, that's the caret symbol, right? And then you know how to do that, right? This one also you could easily do by, this one you can do by hand in particular, right? Because 3 choose 1 has to be 3, right? 3 choose 2, also 3, right? Because instead of choosing 2 girls, think about where's that boy arranged, right? 3 choose 0 is going to be 1. Yeah, so for this one, right, 2 girls, exponent's 2. And then it's for the other one, right? So that's this here. So hopefully y'all can understand how this table is made, right? The rest of you aren't, right? Let's be paying attention. This is, I'm assuming that this is straightforward, right? Okay, so once you find a probability distribution, what are some of the things you calculated regarding a probability distribution? It's what we did yesterday, Monday, the first thing we did, we learned how to calculate this. What did we learn how to, what are some things we learned how to do with probability distributions? Yep, so we did that. We found the probability for each of these, right? In this case, the probability of having no girls is 1/8, which should be the same as having 3 girls, because that's no boys, right? In this case, it's 50-50. Each of these were 3/8. Right? One thing I know, I give my learning objectives, right? If you write those down, that tells you stuff that's important, right? What are you supposed to know at the end? So what did we learn how to do after we learned how to make a probability distribution? What are some properties of a probability distribution? What are some things that a probability distribution has? That's what we just did. That's again, the probability distribution. X is the number of successes. Yeah, we were able to calculate some parameters. That's true. What parameters did we learn how to calculate? Say again? No, what are the parameters of a probability distribution? Well, what a probability distribution is, what is the parameter? What are some, the parameter means values associated with it. Something is with the letter E. The expected value, guys. Do we remember that we calculated expected value, or you just don't remember this at all? So expected value of a probability distribution is the same thing as the mean, right? You have the probability of everything. We calculate the expected value, right? We calculated the expected value of Drippy's gambling game, and we found out it was positive for us. So that meant it was good for us to play, right? What is the formula for expected value? Sum x px. So that means for each, and we can kind of do a different way of seeing this, all right? So expected value equals 0 times the probability of having 0 girls. What's the probability of having 0 girls? 1/8 plus 1 times the probability of having exactly 1 girl, which is plus 2 times the probability of having 2 girls, which is 3/8. Hopefully everyone understanding how I'm calculating this. Plus 3 times the probability of having 3 girls, which is, no, there's definitely a way to simplify it. We're getting there, all right? Not generally speaking, but for a binomial distribution, there's a much easier way to do this, right? So if we do this, I got 3/8 plus 6/8 plus 3/8. All right? 3/8 plus 6/8 plus 3/8. So that is 12/8, which is 1.5 girls. That is the expected number of girls. Well, of course, no family actually has, right? If you did this many times over and over again, right? This is what would happen on average per trial, right? Everyone gets that. Yes, so what you did, that's absolutely true, right? So this is what Mars is saying. He's saying, I have 3, right? And 50% of them, or 0.5 or 1/2 are girls. That's 1.5. That's the intuitive method. So this formula right here works for any this discrete, right? Probability distribution, right? But for the binomial, they're all independent, right? You're right, but we just showed it, right? here's the intuitive method. I have n fixed trials. In this case, I had 3 trials, right? On average, half my trials are successful, so I would expect 1.5 successes. So this is very intuitive if you think about this. The expected value for a binomial distribution is simply equal to NP. You know this. You just didn't think you did, right? Mars knew this. He just said, right? Do we all get why we would expect, right, a family, right? If you had to guess, half of the children are going to be girls, right? So if there are 30 children, it's a lot, right? 15 of them would be girls, right? If it's not whatever, it's a kindergarten class, right? Same thing here, right? If 10% of people are left-handed, I have 300 people, that's an estimated 30%, an estimated 10% of that 300 would be left-handed, right? You simply multiply the probability of a success by the number of trials, right? Drippy shoots 57% from the line. If he is shooting 10 times, you expect 5.7 successes. This works for the binomial distribution because they're all independent, right? So I am going to give you, on the celebration, a question where I will ask you the expected value of a binomial distribution. Do it the easy way. There are always 2 or 3 students who do this. Takes a lot of time, especially if they're more. Times it takes up to several pages, right? What are the other questions on this? Expected, right? You should be able to know how to, we got these numbers and you should be able to know what are the parameters of a probability distribution. Questions? What's the other parameter that we learned how to calculate of a probability distribution? It's right after expected value. If you found that in your notes, you should find this. The variance and the standard deviation, which are really just the squares, right? And I gave you a formula for doing it. It was kind of cumbersome, right? Well, the good thing is for a binomial distribution, it follows the same pattern. So notice here's your mean, NP. All you do is you multiply that by Q, which is the same thing as 1 minus P. So you could write it this way, or you could say this is N times P times 1 minus P. That's your variance. And then if you just remember your standard deviation is always the square root of that. Parameter is like a statistic, but it's of everybody, a population. So it's something that describes a population, right? Which, Mars, this makes sense. This mean, right? 1.5 girls describes all possible, it describes like how the distribution, right? What's the most likely outcome, right? The variance would tell us how spread out those outcomes are, right? I mean, it's nonsensical, but just imagine for a minute that this was a thing. You could have a world where every family had 1.5 girls. I mean, you can't imagine, but right. But that's not the case. Some have 0, some have 1, some have 2, some have 3, right? So that one's a more spread out version, right? Same mean, different variance / standard deviation. So let's calculate the variance and the standard deviation here. So from the girls example, N was equal to what number? 3. P was, yeah. And then in this case, Q would be 0.5, which is also happens to be 0.5. So Q is just the probability of a failure. Or if you don't want to memorize Q, just write 1 minus P and use that each time, right? So this ends up being not 1 minus X, 1 minus P. All right, and then the unit here is weird. So the mean was 1.5 girls. So the variance is in square units, it is 0.75 girls squared. no idea what the hell that means as a unit. Variance is weird that way, right? But standard deviation is simply the square root of your variance, right? Notice that. So that's 8.7 girls. Sorry, 0.87 girls. Yeah. And a lot of times the units just don't, you just can't think of, like, you're like, I just can't even imagine what the heck that means. But you just roll with it because the standard deviation makes sense. Oh man, I screwed this up. All right, so I'm gonna go off this. I'm gonna turn this off for just a second. I noticed I need to do something. Some of you might have full scholarship. Some of you might be taking out student loans. I got $30,000 in student loans right now, so that's fun. So you might think, well, I bet you Mr. Neff makes a lot more money than I do. I probably do, but your net worth, if it's positive, might be better than mine. Although my wife has a PhD. The one thing about a PhD is it's free, but yeah. All right, so let's say instead of exactly 3, let's say 3 or fewer, right? That's why I'm going to change this. So I'm going to write 3 or less. All right, so it turned out that in 2016, right, 11.3% of people default on their student loan. That's bad. Hopefully it's a lot less now. The Biden administration did a lot of income-friendly things, right, for student loans. So let's try to answer this. So is this binomial? So we're having a group, we're selecting 10 students, right? Is this a binomial situation? Are you doing a fixed number of trials? Is the probability of success the same in each trial, and are the trials independent? And are there 2 outcomes, everybody? Yes, all right. It's easy now, but when you're on taking that celebration, right, you're gonna have a question that's about something completely different. Make sure to know when to use the binomial distribution, when not to. All right, so let's fill this out. P is the probability of one success. Success is used here loosely, and it's the probability of the event occurring, which is 11.3%. You might say it's definitely not successful if you're not doing well if you're defaulting on your student loan. Success is meant in terms of what the problem's asking about, right? So I'm doing this event, right? I'm selecting a student, right? Each time I have roughly an 11% chance of picking a student who defaults on their loans. That's not good. That's way too high, but that's the case. How many trials are being done here? That's N. 10. Okay, I didn't put X here because I said 3 or less. So there's really not, yeah, go ahead. 10 is. 3 is the number of, well, we'll get to that, successes, but it's not just 3. If I said exactly 3, X would be equal to 3. Does everyone follow? What I'm asking here is what is the probability that X, oh, not greater than, sorry, 3 or less students defaulted on their loan. We don't have a formula for this, and there really isn't one, but we can break this down. So if so let's just go through the possibilities, right? We can find out each possibility individually. So if X is less than or equal to 3, our possibilities are that X is equal to 0, that works, or 3. So we have to find out each of these separately. Yes. You got to read the question, right? And sometimes, but like these, that's not, I mean, it sounds like I'm being sarcastic, right? But no, like, wow, what did I hit with my elbow? Jesus Christ. All right. I shouldn't say that this is a Catholic school. I shouldn't be saying that so casually. My mistake. All right. So I'm not being sarcastic, but sometimes, right, the hardest part of these questions is pulling stuff out of the question and translating it to math, right? You read that, you need to read n equals 10, right? But it's not there. And it's hard for me to give an exact formula for that because English is more, many of you probably are bilingual, and Spanish, pretty much every language that people speak have many different orders you can construct the same sentence. So I don't want to say it's the first word, it's the word right before if, it's the word right after if. You just have to kind of get used to that. Okay, so to figure out the probability that X is less than 3, I have to add up all of these, right? So remember the formula is n c x p to the x p minus 1, aka q, to the n minus x, right? So for 0, that's 10, choose. Well, that one we can kind of do, right? How many ways would there be for none of the students to default on their loan? 1, right? How many ways is there for no student to default on their loan? 1, right? Everyone does not default. No, I'll just write it out this way. This is 10, choose 0, right? Following the formula. 0.113 to the power of 10. Just so to write this out, let's see, that is 0.887. Oops, this is 0. That's 10, my mistake. Right, x in this case is equal to 0, so I just plugged 0 in for x into this formula. The what? Q. This is 1 minus p, right? If 11.3% default, 88.7% do not, right? So here we're saying, what's the probability that x is exactly equal to 0? So that means these, by all the way, are going to become 1. This is the only part, right? Each person in that row, 88, 89% of the time, the first person won't default. When the first person doesn't default, 89%, the next person won't default. You do that 10 times. So then you just do this each time, but you only change a little bit, right? So this would be 10. C1. Now what's the new exponent of 11.3? Just look at the formula. It's x every time, so the new exponent is 1. This exponent will be, goes there. So x is equal, so this, we just handled x is equal to 0. We're handling x is equal to 1. So this is 9. Notice each of these sets of exponents should always add to 10. What do you mean by separate equations? So I can tell you that it's not an equation at all because there's no variables there. But to get what you're saying, this corresponds to that, and this corresponds to this. Yeah, I have to write it out because there's no, right? And we just do it for each of these, right? So that's the probability. In yellow, no students default, exactly 0 students. This is exactly 1, right? I'm just changing the x values in this equation. So now this is n choose 2. This is 113. What's the exponent going to be for this first term here, everybody now? 2, which means the exponent for the second term should be, yeah, right? This is the probability exactly 2, the first 2 default, and then the last 8 don't, and then this is the number of ways to arrange that, right? That's how we got this. This is the same thing every time. Yeah, we're doing 4 different ways because there's also none, right? And this would be a shit ton of stuff. You put this in your calculator. These are the answers you're going to get for each of these. You add them up, you get the probability that at most 3 students default is, thank God, 98% roughly. Yes. So this is the probability that 3 or fewer students default. And the only way we could solve that was figuring out the probability of 0, 1, 2, 3, and adding those 4 things together. Luckily, part C, I left a lot less space for us to work in. Luckily, that's going to be much easier, right? Mars, you told me, how did you get that 1.5 girls in that last example? Right, and they're each equal, right? So you took, that was a binomial, right? So you said that the expected number, aka the mean, is equal to n number of trials times probability of a success. Right? It just was 3 1/2 before, right? Here, how many trials are being done, everybody? How many trials? 3 or 10, students? 10. You are doing 10 trials. You're choosing 10 people. 3 just happen to be the largest number of successes that we were interested in there. So this is 10 times, what's the probability of a success here? 98 was the percent of 3 or fewer successes if you did it 10 times in a row. So P just means the probability that any one person will be a success. This formula, you should have been able to tell me this before you came into this classroom today. 11% of students default, so roughly 11% of these 10 students will default. That's what you would expect. Fairly intuitive, right? 37% of people drive a stick shift. I'm just making it up. How many out of 100 would you expect to drive a stick shift? 37. That's because 30.37 times 100 is 37. If I said 80, you would multiply 0.37 times 80. Same thing here. Number times probability gets you your expected number. Right, and we don't actually expect that out of 10 students, but we expect if we repeatedly chose those 10 students, right, and counted how many defaulted, on average, doing this experiment many times, you would average out to 1.13 students. Yes, that formula you can only use for binomial. Luckily, a lot of stuff is binomial, right? And then the standard deviation formula, I just gave it to you. What's the square root of? You remember this. I just gave this to you in the last slide. So that would be 10 times P, which is 113. Oh boy, it's going to have to fit in there. Make it green so it's easier to read, at least, if on top of that red. You type that in your calculator, you will get almost exactly 1. So the variance would be that squared, but so the standard deviation is 1 student. That tells you how spread out this is, right? And then this tells you where the center is. This calculation right here, this is a pain. It's very long to do, right? And I didn't even make you type it in your calculator. I could have, right? I could have just as easily said that there's a group of 100 students, and I need you to figure out what's the probability that exactly 37 or fewer default. In which case you would have had to done probability of exactly 0 plus probability of exactly 1 plus probability of exactly 2 plus probability of exactly 3, right? Bobby's already giving me a look. I don't want to do that, right? Now, is there a formula that avoids you having to do that? No, but your calculator can do all that for you faster than you can type it in if you just tell it that's what you want it to do, okay? So let's learn how to do that. So, right, to save you time, because I might ask that 37-100 question, let's get our calculator. Let's go over some things. So I will tell you what each of these things are, right? So I'm going to do each of these examples. This vars button means variables, right? You can do this thing. So notice here it says the word vars. Above it, it says DISTR. You can guess that that stands for distribution. Okay, so some of your calculators will be a little bit newer looking than me, right? Yeah. All right, so second, distribution, right? You have a lot of these distributions. All the way at the bottom is our binomial PDF and CDF, right? I'm going to use our PDF first, and then we'll use our CDF, and we'll figure out what that means. So this is the format that you type things in. So you have N, P, and X. Those are numbers you have to decide, right? So typically we decide, like I found out P, then N, and then X, right? Your calculator is NP then X for whatever reason. So N, the number of trials, let's say it's 5. This is the drippy example. Yes, so let me give you what this means. So this is a binomial distribution where there are N trials, right? The probability of a success is 57%. 3. So this is the probability. So and this is actually exactly what I use for Drippy, right? So this is the probability that he makes exactly 5 out of, or 3 out of 5. Yeah. You have to have the comments to make sure you specify what each part is. You just type in. Yeah, yours is newer, right? So you just type in what you need to. Down there, yep. Yep. Trial, yep, that's easy. And then you just press, yeah, then you just go down to the bottom, press paste, and then hit enter. It says the same thing.
Oh, I read that as 0.
It's all good. It's all good. I know it's been a long day. Yeah, Bobby. See, you have a newer one, right? So that you don't have to remember what order to put it in, just put in the stuff it asks you for. So 5 is the number of trials, 0.75 is the probability of a success, 3 is the number of successes. Yes, it's written in a way that's weird. But your calculator, it's just the order that it takes it in. What do you mean F? It does, but don't worry about that F. I have no idea. It just means binomial distribution, okay? Now, let me tell you this other one, right? So now I could have done this by using the formula that I taught you guys earlier, right? Notice this is the same as 5, 3 times right? I taught you how to do this without this earlier, yes? This is the formula that we've been using a chajillion times. Yes. 5 choose 3, right? This is N choose X, P to the X, Q to the N minus X. Yes, so this is the shorthand way of doing it. Now, I might not even taught you this if this is all your calculator could do, because this isn't that great, right? It saved me a little bit of time, but not too much. But the CDF is what's really powerful. So let's go show you that. So again, second VARS distribution. I'm getting there, Mars. It's all good though, right? I know you want to know, all right? So it's more, right? What's going on here? The C stands for cumulative, which is a word I always have trouble saying. If I say that you have a cumulative final, which you do in this course, by the way, that means that the final is on everything, right? Everything that accumulated. So what this means is, what is the probability that there are 3 or fewer successes? Yes, and this is 3 or fewer. This one's much more powerful because, right, I made you do more work than you needed to on this previous problem, right? Yes, exactly. So let's try this. So instead of having to type all this in, all I needed to type into my calculator, let's type that in. Oh, not this one. I gave the total wrong values, right? Yeah, 10. That's the number of trials. Try typing that in, and you will get, yes, we want 3 or fewer students defaulting, so 3 or fewer successes. Yes, because 0 is fewer than 3, right, if you think about it, yeah. Notice doing that did it much faster, right? So you might say, why didn't you teach us that at the first place? Well, then you wouldn't have appreciated how good this is, because it's really a pain to do it the other way, right? That's the CDF, right? PDF would just get us any one of these. So the PDF with 3 would have just given us just the probability of exactly 3. So if I want to use it, say again? Yeah, if I use 3 for my PDF. Now, there is no way to do more than that many or more, right? So, for example, let's say I wanted to figure out, let's say I still had n being 10. Let's say p is, you can use the complement. Let's say, let me just make this up, right? And let's say I want to find out the probability that x is greater than or equal to 5. There is no more than, right? So you want to calculate the probability of the complement. What's the complement of an event? The opposite, right? So they're either 5 or more. Well, no, because 5 would overlap then. Let me show you. Yeah. Let me show you what I'm doing here, right? Suppose these are the numbers, right? 10 trials, probability of success, 90%, right? So 0.9. And I said, I want you to find out the probability of 5 or more trials. You would say, Mr. Neff, I'm going to have to add them all up because my calculator has a shorthand for that many or less. It does not have a shorthand for that many or more. Everyone following, right? But, all right, the probability that x is 5 or more, what's the opposite of being 5 or more? What? That's not the opposite. 5 or more is 5 through 10. Yeah, 0 through 4, right? I have the scale, think of the scale 1 to 10, right? If something happens 5 or more times, the opposite of that is that it happens 4 or fewer. Does everyone get that? Right? And it's not 5 because if I put 5, right, then 5 would overlap, right? 5 would be in both categories. So I'm doing 4 or fewer because that one, my calculator has a shorthand for doing. Yeah. That must be, yours is newer, so I don't, did you use binomial CDF? I guess that's just, I mean, I guess then you can do whatever you want. What I mean by that is you can just say the lower is 0 and the upper is 4. So yours is better. Yours, you don't have to use tricks like this. I guess. I don't know. I don't have yours. Okay. Yeah. Then you're gonna have, well, if you use that one, then you have to follow. Then you have to use this trick. The internet exists, guys. Right? If you don't know how to do something on your calculator, Google how do I do X on my TI-80 whatever, and you'll find like 30 videos of that. Right? All right. So really have time to start the next thing. This is unfortunate. But I want you guys to practice, right? So let's see. I'm going to have you do this. So this is your exit ticket. This is like a field. I'm not grading this. I'm just correcting it, right, and returning it to you, right? Did we get that distinction? Right? So just try to do these. You can talk with each other, right? You get feedback. Isn't that what you want, to see if you can do this? Sure, in your mind. Learning is practice makes perfect. Yeah, don't look at the front side of this. It's just blank page to give you space to do this. It's just easier if everyone has the exact same page size and stuff. If I have you tear a page out of your journal and give that to me, right? Like some pages will be different. No, I'll end up losing them and I won't end up getting them back to you. Yeah, we don't, front side's irrelevant. It's a blank piece of paper, right? Try to solve this. You can use your calculator, but just tell me, if you use your calculator, write down what you are typing into your calculator on the sheet so I can give you feedback, right?